Briggs, a statistician of the stars, and I don't know if you know it, but a couple of weeks ago, a UFO hit United Flight. What was the name of the flight? I can't memorize these things. You'd think I would. 1093. It was on its way from Denver to LA. It was at 36,000 feet, and I'm going to put a picture of what happened. I'm going to put a picture, and it was whacked. It was almost 7 miles straight up, and it was whacked right at the corner of the windshield. You'll see this picture. Right at the corner of the windshield where one windshield met another, and 6 inches to the left. I wouldn't be so lighthearted reporting this thing, because as it was, the glass was projected in. It cut up the pilot's arm pretty badly and so forth. And, you know, the pressure on the plane is such that the glass might have blown outward and so forth, but depending on how fast this thing was moving, it could have crashed inside the cockpit and wreaked all kind of havoc. Now, I say UFO because at the time I wrote this, it was unknown what it was that hit it. And now it seems that the company that makes a certain weather balloon admitted that it was probably their weather balloon that was up there. It goes all the way up to the stratosphere, it takes measurements. The Weather Service, I used to do this. I was in the Weather Service, National Weather Service, back in, 92, 93, something like this. And twice a day we sent up weather balloons. This was in Sault Ste. Marie, Michigan. Filled them up with, in our case, it was hydrogen, hydrogen gas, which is, you know, a little unstable and so forth. And we sent these radiosondes up twice a day, and occasionally people would bring in a spent radiosonde back into the station in Sault Ste. Marie, Michigan. So these things happen. They go up, and they're very lightweight, those particular things, and. But the planes are moving pretty fast. They're moving, what, 600 knots, 500 knots, something like this. But not a lot of air up there, so the damage is still substantial. So, but the real thing I wondered about was, what's the probability of so I want to know what are the chances a debris from space. It could be space debris hits this thing. So I want to know what are the chances that space debris hits a plane, your plane, an individual plane, as you're flying, you know, from Detroit down to Miami or Tampa or something like this, like snowbirds do. What are the chances space debris hits an airplane? And it's not an insignificant thing. It turns out the FAA has looked into this. They're mandated by Congress to report on this. You don't know. There's so many laws. I don't even know how many laws. Maybe even most of them, or all of them even, mandate that some agency report to Congress or the presidency or the president's office on this, that, and the other thing. And this only causes the bureaucracy to grow and to grow endlessly because they have to write and continuously write reports. But in our case, this is helpful. The FAA went to some organization and they asked them, you know, what's going on in space and so forth. Obviously, they track, the NASA tracks, I want to get the exact number for you. I want to get there's, the FAA report says by 2035, if the expected large constellation growth is realized, a constellation of satellites is a bunch of small. It's not just a satellite. It's a group of satellites put up there for a purpose, like Starlink, you know, for particular telecommunications network or something like this. So these constellations of satellites are only growing. And they're expected to have 28,000 re-entries a year of everything from, I think it was 10 centimeters on up. And they say, this is the FAA's own report now, this is not just Briggs saying this stuff. The number of individuals on the ground, this is not on a plane, no, this is the number of individuals on the ground predicted to be injured or killed by debris, surviving the re-entries of these satellites being disposed from the constellations would be 0.6 per year, okay? 0.6 persons per year by 2035 they think will be whacked by falling satellite debris. And this is the FAA saying this, not me. I'm not saying it at all. I'm just repeating what they're saying. Well, this is worldwide. This is not the United States of America per se. There's people all over, and these satellites are coming down everywhere. Pieces of them are. Eventually, one of them is going to conk somebody. But that happens with meteorites too. A mini bolides or something, rocks from space come down, and they do whack people, and they might whack planes too. Right? Planes are up in the air, they're flying around the atmosphere, in comes a big rock from space, and you could be on the plane that's hit. And a piece of debris that's 10 centimeters or 4 inches or so in civilized units or more, that's made of metal and is not some radiosonde made of partly of styrofoam and so forth. Why, that thing hitting a plane, and it's coming down at its own fairly good rate of speed by the time it burns up, and if it's that size and it hits a plane, well, that's going to cause some difficulties. So they track this stuff. They do track this stuff, and they do things. So they're going on to say, this is still the FAA, that some disease fragments would be a hazard to people in aircraft. Now, this is on the ground. They're going to say by 2035, 0.6 persons a year would be whacked. But they say in the air, projecting 2019 global air traffic to 2035, and assuming that a fragment that would injure or kill a person on the ground also would be capable of fatally damaging an aircraft, which is a good assumption, the probability of an aircraft downing accident, in other words, crashing, is 0.0007 a year. This is the probability. This is their conditional probability per year. They calculate this probability. This is the probability of a crash given whatever evidence that they have equals 0.007 per year. That's a cumulative number based on all the numbers of flights that they give and so forth. Now, NASA tracks, I have you can go to wmbriggs.substack.com. I have a picture from NASA's website. They track 25,000 objects that are 10 centimeters or larger, and that number is only growing. They have models to look at the reentry of these debris, and these are, I'm also often picking on models and so forth, but these are very simple models using just simple, the Earth is rotating, the atmosphere is like this thing is this heavy, it's coming in at this angle. These are fairly good models, but the problem is the observation of these things, if they're off just by a little bit and at the speed they're moving, they could be off by, I think it's, I forgot exactly the thing right there. It's, right here. The FAA says reentry time can be off by 10% of the orbit remaining. It doesn't sound like a big error, but given that a low Earth object, satellite object, some kind of debris, circles the globe in just 90 minutes over 20,000 kilometers per hour, at 10 hours before reentry, the likely reentry area is 27,000 kilometers long. Even 60 minutes prior to reentry, the potential area over the debris may fall is still over 2,000 kilometers long. So they have these models, and I think they're reasonable models based on very simple physics, but they're still going to be off. They're still going to be off by plus or minus 2,000 kilometers. So you're not going to be able to, know when to duck and cover or anything like this. It's just not going to be possible. So it's going to happen. So what I wanted to do, here's what they said here. The latest numbers reported in 2021 said, quote, there was about a 7% chance of at least one person on the planet being seriously injured or killed from debris from space vehicles. That's 7%. That's not an aircraft crash. This is a person. So the probability of a person being whacked, given their evidence, this is their numbers, is 0.07 per year. So what I did, and I'm going to put in here, I thought, well, all right, I'm going to accept this number. I don't know if it's good or not. I mean, you could look at all the technical discussions and so forth. It all seems reasonable to me, but I don't know enough about it to criticize it more than that, but it seems not unlikely. And don't forget, we just had, these things do happen. And, things come down in space all the time, and they are tracked. They make the news and so forth. So it's far from impossible. So what I did, and it looks like this, you'll see the picture. Here's a cumulative chance of being hit from the years from 2025. The years from 2025, I think I did 10 years out. And it starts at this 0.07, and it goes up to 0.5, and it goes like this. So in other words, 0.5 here. This is a cumulative probability in the sense that this year, there's a 7% chance one person will be whacked by something from space debris. By next year, the probability of at least one person getting whacked goes up to, I don't know what it is, 8%. By the time 2 years rolls around, we got 15% chance at least one person would be whacked. And by the time we get out 10 years, we got like a 50% chance one person somewhere will be whacked by debris from space. All right, that's easy to calculate. I'm not going to go into that. It uses the inclusion-exclusion formula, which we did before on the probability of large rocks from space. I'll have the link to that. So the point of it is, though, if all these assumptions are correct, it's eventually going to happen. I mean, there's 8 billion people plus or minus roaming around, and satellites are only increasing, and they break apart up there, and stuff is falling down. Somebody's going to get hit. Now, I thought about this when I wrote this. When it happens, though, the conspiracy theories are really going to fly because, here's old Joe walking along and some people seeing him walking along. Next thing they know, boom, he's plastered. Nothing left of old Joe because this thing's coming down from space at a pretty good clip, maybe even followed by a large boom. Nobody's looking guilty, nobody's firing anything at him, but old Joe is gone. And who's going to believe it was something from space or it wasn't directed from something from space? People are going to go nuts with these kind of conspiracies. All right. Now, for the aircraft, it's similar. For the aircraft, it's similar. It's the probability of an individual crash for aircraft downing. They say they have different numbers. At one point, they say it's this, and another time they say they round this up to 0.001. It's a little inconsistent. So I use the 0.001 number instead of the 0.007 number. In other words, we want a probability of an airplane crash being, whacked from space. And one of the agency they hired out to do this, some corporation said this, they say this. I use that. And I have another picture like this. Basically, it goes from, I'll just use this right here. It goes from 0.01 in 2025 all the way up to roughly 0.05. So there's a 5% chance by 2035 aircraft goes down. At least one aircraft goes down because of space debris. That still does not give us the probability of your particular plane being whacked. That's the probability. This is the probability of at least one plane anywhere in the world. And I forgot, I looked it up. I looked up the number of flights per year. There's 36.4 million flights here. 36.4 million flights per year of passenger jets. That's a lot. So that's why the probability is so high. You got a lot of these things going on. They're all over the world, and there's even a particular place where they're at, obviously where most of the population is, where most of the planes are at, and that's where the debris is most likely to come down, and you can work all that out, and that's how they got that 0.001 or a little bit smaller probability here. But that works out to be about a 5% chance in the next 10 years one plane goes down because of this. Now, if you want to work out the chance of your own plane, basically you have this formula, which is 1 minus p to the n, and you solve for p. And this equals 0.00, this equals 0.001, or you can put in 0.007. The n is this number here, or whatever number you think might be relevant. And you can work this, you just solve for this p, and this p turns out to be, for your particular plane on any individual voyage, is about 1 in 100 billion. So it's pretty small. 1 in 100 billion is a pretty small chance that your particular flight will be the one that gets whacked. So, and there's all kinds of other things that there's about various sources and definitions, but planes go down, large crashes occur from 1 to 5 times a year from other reasons like pilot suicide. Pilot suicide, murder of the passengers, that happens all too common. Something mechanical, that kind of thing. So there's those probabilities are much bigger. That gives that's basically either 1 divided by 36.4 million. That's the probability, or 5 divided by 36.4 million, depending on your sources. That's much bigger than 1 in 100 billion. So you know, don't worry so much about rocks from space, but check out your pilot. Make sure he's got a happy marriage before you get on there, or it's not some DIE hire or something like this. Okay, that's it. I have the full details for this kind of a thing at WMBriggs.substack.com. I'll have the link for you here, or WMBriggs.com. And you can look at the exact equations and pictures and so forth. That's it for now. Thanks very much for listening.